In this video we are going to solve the LP from the practice quiz using the simplex method. So we have this two variable LP, and the first thing we do, we convert it into the standard form. And also we'll set it up in a way that's suitable for the tableau format, meaning that all the variables need to be moved to the left. Alright, so first of all we start with row 0. Z is equal to 5x1 plus 4x2, but because we move all the variables to the left, it will be z minus 5x1 minus 4x2 equals 0. This is row 0. Then the first row we convert it into equality by adding a slack variable. So we add the slack variable s1, and this is equal to 6. For the third constraint, we also add a slack variable. We'll have 3x1 minus x2 plus s2 is 6. Okay, so now we fill in the initial tableau. We have for row 0, the coefficients are, of course, for z in row 0 it's always 1. Then for x1 it's negative 5. For x2 it's negative 4. Then we have the remaining parts of row 0 pre-filled already. Okay, so now for the first constraint, the coefficient for x1 is negative 1. For x2 is 3. Then we have the coefficient for s1 is 1, for s2 is 0, and the right hand side is 6. And our basic variable in the first row is s1. And finally, the last row, we have 3x1 minus 1x2 plus 0s1 plus 1s2 equals 6. This completes setting up the step 0 tableau. We see that there is a column here for the ratio also, but this is not really a part of step 0. It's put as an extra column in step 0 just to save space, so we don't need to copy it again. But it's really a part of the first step, so we'll need to do the ratio test when we perform the first step of the simplex method. And we start performing the first step of the simplex method by determining the entering variable. In the problem conditions, we are specifically asked to use the Danzig rule to select the entering variable, meaning that we are taking the variable with the largest negative coefficient in row 0 as our entering variable. And we have negative 5, negative 4 here. Therefore, we'll pick x1 as our entering variable, and we will perform now the ratio test. For the ratio test, we use the column corresponding to the entering variable, and we are focusing on these entries right here in this column, and also we are looking at the right hand side the values. Alright, so we need to look at all the rows where the entry in the entering column is positive. Alright, so there is only one such entry in the entering column. So the ratio test doesn't apply to the first row, and again the physical meaning of this is that because the first row doesn't restrict the increase in the value of x1, we can push it to plus infinity without violating the first constraint, but we would violate the second constraint at some point. And the highest increase allowed by the second constraint will be given by the ratio of the right hand side here to this coefficient. So it's going to be 6 by 3, which is 2. So this completes the ratio test. This row is the winner of the ratio test. And now we are going to perform the pivot, and we'll obtain the step 1 tableau as the result. So we start performing the pivot because we need to have the coefficient of 1 at this position right here. So we divide this row by 3. And as a result, we'll obtain 1 at this position, and then negative 1 over 3 next, so negative 1/3 here. Then we'll have 0, 1/3, and 6 divided by 3 is 2. And now the new basic variable in this row is going to be x1. x1 enters the basis. S2 leaves the basis, so we'll put x1 here. Okay, And then to compute the entries in row 0 and row 1, we are going to use this new row that we just produced for the entering variable. We will multiply this row by the negative of the coefficient we have here, and we'll add it to the corresponding row. So for example, to obtain the new row 0, we are going to take the old row 0, which is given here, and then we'll add it to 5 multiplied by the new row that we just specified here. Alright, so multiplying this row by 5, we'll obtain 5 here, negative 5/3 here, 0, 5/3, and 10. Okay, so now we need to add these values to the entries in row 0 of our original tableau to obtain the new values in row 0 of our tableau. The coefficient for x1 as a result will become 0 because, again, we multiply 1 by 5 and add it to the negative 5 here. So that's how we actually picked the multiplier for our row in order to make sure that we have 0 here. Okay, so then next we multiply this by 5, negative 5/3 plus negative 4 is going to give us negative 17/3. This is already filled in for us here. Then 0 times 5 plus 0 is still 0. Then 1/3 times 5 is 5/3 plus 0 from here is 5/3. So far everything is correct. And then finally 5 times 2 plus 0 gives us 10 here. Alright, row 0 is done. Now for row 1, since the coefficient of x1 is negative 1 here, we just need to add the old row 1 to the new row 2, and we'll obtain the new row 1. Alright, so you have 1 plus negative 1 is 0, then 3 plus negative 1/3 is gonna be 8/3. Okay, so then 1 plus 0 is 1. Then we have 1/3 plus 0 is 1/3. And finally 6 plus 2 is 8. Okay, so this completes step 1 tableau. And next we are going to perform step 2. To start step 2, we need to select the entering variable, and we have only one candidate for the entering variable. This is the variable with the negative entry in row 0, and it's a variable x2. So this will be our entering variable. And then we need to do the ratio test, for which we are going to focus on this column here corresponding to the entering variable. And we also look at the right-hand sides in this column right here. So when we do the ratio test, again, we only need to pay attention to the rows where the coefficient in this entering column is positive. So here we'll just have a dash because we have a negative coefficient here, therefore this row doesn't participate in the ratio test. And for this row we'll have 8 divided by 8/3 gives us the ratio of 3. We are ready to perform the second pivot. For this, what we do, first of all, we need to make sure that the coefficient for x2, the new basic variable in this row, is 1. Okay, so which means that we need to divide this row by 8/3, which is the same as multiplying by 3/8. When we multiply it by 3/8, we'll obtain 1 at this position here. So then 1 times 3/8 is gonna be 3/8. Then 1/3 times 3/8 is gonna be 1/8. And 8 times 3/8 is 3. And the new basic variable in this row is going to be x2. So we see that here, because S1 row was the winner of the ratio test, S1 left the basis, so now our basic variables are x1 and x2. Okay, so we completed one row for the basic variable x2, Now for row 0, the coefficient in row 0 in the previous tableau is given by negative 17/3. Therefore, now we need to multiply this new row that we just calculated by 17/3 and add it to the previous row 0. So then we'll obtain 0 at this position here. Then we need to multiply 3/8 by 17/3 and add to this coefficient, which is 0. So 17/3 by 3/8 is going to give us 17/8, and this entry is correct here. 17/3 times 1/8 plus 5/3, we'll have 17/3 times 1/8 plus 5/3 is the same thing as 17 plus 40 24th, which is the same as 57 24th, which is the same as 19/8. Alright, so we have 19/8 here, correct? And finally, to obtain the right hand side for row 0, we need to multiply 3 by 17/3 and add it to the previous right hand side in row 0. 17/3 times 3 is 17, plus 10 is 27, and we completed row 0. Okay, so the last row that we need to fill in will be row 2, and the coefficient for x2 in row 2 was negative 1/3. Therefore, we need to multiply our basic row for x2 by 1/3 and add it to the previous row 2. So we'll have 1/3 minus 1/3 is 0 here. Then we'll have 1/3 times 3/8, which is 1/8, plus 0 here is 1/8. And for the variable s2, the coefficient is going to be 1/3 times 1/8 plus 1/3. So 1/3 times 1/8 plus 1/3 is going to give us 9/24th, which is the same as 3/8. So put 3/8 here. And we already have the right hand side of 3 here, so let's check that this is correct. So 1/3 times 3 is 1, plus 2 is 3, so it's indeed 3. And the basic variable here is x1. So we are done. My dog agrees with this solution here, it seems. Alright, so now the variable x1 is equal to 3 in this solution, x2 is equal to 3. And we know that the solution is optimal because all the entries in row 0 are now non-negative, and the optimal objective is 27. Done.